So, hello everybody from my side. My name is Oliver Fey from Woodcape Plus in Austria, and in our area, wood materials technologies, we deal, among other things, with natural insulation material. So, my talk today is about the insulating performance of poplar bark and wood. Bark is an available resource which can be used for higher value products because currently this side stream in sawmills is mainly used to produce energy. And we want to show here the potential of bark as a raw material for thermal insulatings. Due to the dimension of bark, it's a challenge to investigate the material. Since the bark of poplar is relatively thick, as you can see it here, we used this species as a model substance in our study. Small pieces that we could fabricate from the bark can you see here. So we cut the wood to the same dimensions because we wanted also to increase the insulating performance by means of a chemical treatment, and small samples are easier to handle here. For our chemical treatment, we applied an acid mixture, then we washed the pieces until pH 7 was reached, dried the pieces and cut them to the final dimensions. Then we assembled 4 pieces to form a sample cube. Because a cubic sample has the advantage that thermal conductivity can be measured in the 3 anatomical directions on one sample. And finally, the 4 pieces were stretched with a polyethylene foil to hold the pieces together. For the examination of thermal conductivity on very small samples, we designed and constructed a miniature heat flow meter with a measuring area of only 25 mm and calibrated for samples of a thickness of 25 mm. For the calibration of our instrument, we used isotropic plastics and cork composite material. Here are the thermal conductivities that we measured with a certified guarded plate apparatus. And we plotted this data versus our mini AFM results to gain a calibration curve, which has a high R-square, as you can see it here. Moreover, we used the calibration materials to analyze if there is an influence of the packaging foil on the test results. That means we measured calibration materials when they were packed in foil and without packaging foil. An effect was only found here for materials with low conductivity as XPS. The packaging foil increased the results about 3 milliwatt per meter Kelvin, which is not much. For the materials with higher conductivity, there was no influence. Then we checked if the composition of the sample affected the results. Therefore, we examined cubes of poplar wood in one piece and compared the results with measurements of our composed samples. We did not find significant differences here. And there are values for poplar wood that we tested with a mini AFM agreed with the literature values also. So we concluded that the data that we determined for bark and wood with our mini AFM is reliable. The density of bark was higher than the density of wood. And with the treatment, we clearly reduced density of both materials, as you can see it here. Poplar bark, when it is dry, has good insulation properties, and we can additionally enhance these properties. Treated bark had approximately 20% lower thermal conductivities than untreated bark. The poplar bark is less anisotropic than wood, and the bark has also better insulation properties than poplar wood, even if the density of bark is higher. So we can conclude that bark is a potential raw material for thermal insulations. And the last message is that we have set up a nice tool to determine thermal conductivity of small samples, for example of modified wood. So don't hesitate to ask or write me an email if you need support or want a cooperation. Finally, I want to thank the government of Lower Austria and Woodcape Plus for financial support, and thank you for your attention.